If PST is also turned on, then during trigger time generation, it will automatically link the trigger time segment to the corresponding PST number as its subset. When performing signal analysis, it will play through all PST time, and at each PST time, it will average, or play through, multiple trigger time segments within each PST. Such combined usage of PST and trigger time provides an effective way to perform signal analysis for a roving hammer test as shown in this reference window. Let's extend the reference window plot for closer look. The test was performed with one vibration response measurement at a fixed location, and a hammer excitation at 12 different locations. At each location, multiple hammering was conducted. First, right mouse click on PST to bring up its menu. There are 12 PST time segments here. Each PST is represented by the blue highlight here in reference window. Within each PST time segment, multiple hammering were conducted at the same location. The hammer location can be recorded under the column of PST name, which can be used for further processing. The unit of these locations are in degree, since the test article here is a circular disc. Next, right mouse click on trigger to bring up its menu. During trigger time generation, when a trigger event is found, its corresponding PST time will also be identified and automatically assigned to this PST column, such as PST1, PST2 and so on. With both PST and trigger time established, we are now ready to perform signal analysis and generate the frequency response function at the 12 different locations. Turn on cross-spectral analysis. Generate PST. Twelve FRF are generated here, which are corresponding to the 12 hammer location. Each FRF is generated by averaging over multiple hammer events with each PST. For more information about roving hammer test, please refer to roving hammer in M1 menu.